Okay, this question is actually an organic loading rate question, and it is asking for the answer in pounds per day per 1,000 cubic feet. So again, we've got our magic three-letter word here, per, that means that we're going to have to divide. And we're going to be dividing a number in pounds. So pounds per day. We're only talking about 1 day here, so we don't really need to worry about pounds per day. We're just going to use the information to calculate a figure in pounds. And that is going to be divided by, now pay close attention here, it is asking for pounds per day per 1,000 cubic feet. And what that means is we're going to take the dimensions of the trickling filter to calculate the volume in cubic feet. That's going to include the diameter as well as how deep the trickling filter is. That's going to give us a volume in cubic feet, and we need to take that volume and divide it by 1,000 to get a number in 1,000 cubic feet. It's almost kind of like a made-up number just for purposes of math problems like this. So the first thing that I notice is that it's asking for pounds per day. As we've discussed in class, there is a formula called the pounds formula in wastewater that's used quite a bit. Again, if you haven't looked at the material in a while, you maybe need your memory refreshed a little bit. We calculate pounds based on a number in million gallons. We're going to have a solids concentration in milligrams per liter, and then we have a constant of 8.34. So in setting up the first part of this problem, it's going to look like this. 900,000 gallons per day is 0.900 million gallons per day. To do the pounds formula, we have to have a number in million gallons per day, so we need to take that number of gallons and divide it by a million. So 900,000 gallons per day divided by a million is going to come out to 0.9. So 0.900 or 0.9 million gallons per day times 200 milligrams per liter times our constant of 8.34. If we multiply that all the way out, 0.9 times 200 times 8.34, we're going to get a number in pounds, which when I multiply it out comes out to 1,501. So 1,501 pounds. Now the second part of our equation, we're going to take the measurements or the dimensions of our trickling filter. So I'm going to calculate the volume of the trickling filter by radius. So if the diameter is 90 feet, that means the radius is 45 feet. 45 times 45 times 3.14 is going to give us a surface area times the depth, 10 feet deep. So surface area times depth is going to give us a volume in cubic feet. So let's multiply this out. 45 times 45 times 3.14 times 10 gives us 63,585 cubic feet. But remember, they're asking for an answer in pounds per day per 1,000 cubic feet. So I'm going to take this number, 63,585, and I'm going to divide it by 1,000. Which gives me, if I divide that by 1,000, I come up with 63 point, we'll round up to 63.6. So when we go to plug these numbers in and get our final answer, we're going to take our pounds. Remember, 1,501 pounds per day. And we're going to divide that by 63.6. That kind of made up number of 1,000 cubic feet. So when we divide 1,501 divided by 63.6, we get a number 23.6 pounds per 1,000 cubic feet. So you have to be careful with these problems, with the loading problems, when we're talking about organic loading, because they want that number in 1,000 cubic feet, and if you're not careful, if you don't convert the 63,585 cubic feet, if you don't divide that by 1,000 and get that kind of made up number of 1,000 cubic feet, you're going to get the answer wrong. So that's an example on how to do that problem number 3.